Hello, students. Mark here. Just want to go over week 9. We're going to talk about hydronic control systems, service maintenance. So I'll get right into it. We'll just zip through a couple things here. Um, First of all, we're going to talk about operational checks or things that you want to do with a boiler to take a look at, make sure that you're maintaining it correctly, and we'll just kind of walk through each one. On a boiler, you might run into something called a check valve. A check valve is a valve that allows the water only to go in one way. Sometimes they'll stick closed, or they might stick open, or sometimes you'll hear them make noise like a chattering noise or a clicking noise, and that's something that's stuck inside of the check valve. Might be a piece of rust or something. So some of these can be taken apart and cleaned up. When you do that, you just want to make sure that you have something called isolation valves on either side of it. If not, you'll get the full power of the water rushing out through that opening. So you'll get real wet. Hopefully, it's not hot water, 180-degree water, which means now you're hurt. But anyways, usually it's a cold system when you do it, or and make sure that the pressure is off, and you can change out that valve when you need to. The pressure reducing valve is another valve, and pressure reducing valve, I'll just draw you a quick uh, something here if I can. I can't. Pressure reducing valve is a valve that reduces the water pressure from 60 psi down to 12 psi for the boiler system. If your boiler is running at a higher pressure, maybe it's running at 30 psi or even at 60 psi, what'll happen is your relief valve will relieve the water out. Remember, your relief valve relieves the water at 30 psi. Your boiler is supposed to run at 12 psi. So you might have some kind of leak by or something in your pressure reducing valve. And remember, this valve supplies water to the boiler. And so if the boiler loses some water, the pressure reducing valve will replace that water. Inside of that pressure reducing valve is a what we call a back check valve, which is will not let the water go backwards. To increase the pressure, so to go higher up to 12 psi, you screw the nut clockwise and counterclockwise for decreasing the pressure. You'll see the bolt on the top of the head there. So here's another diagnostic of the pressure reducing valve. You'll see some of them have a little lever at the top. We call that a fast fill lever. When you lift that up, you'll actually bypass the regulator, the 12 psi, and you're just allowing water in until you can get the system filled. There's a very small amount of water that comes through a pressure reducing valve under its normal circumstance. So once you've set the pressure and everything, you might adjust that lock nut and to the 12 psi. That way you know where you're at. But if you want to fill it fast, you pull up that little lever at the top. There's two types of expansion tanks. One of them is a diaphragm expansion tank, and one's called a non-diaphragm. And we usually see on most common boilers, you'll see the diaphragm type. We've talked about those at length during different times of this course. But you'll see that the diaphragm type should be set and make sure that the pressure is at 12 psi. If the pressure is higher in the diaphragm, then you might something might be wrong with it, or maybe the bladder is broken, or if you see any water leaking out of where the air should go in, we know you have a busted diaphragm in there. The second point we haven't talked about yet is this type of expansion tank. And this expansion tank here is a tank that's usually up in the ceiling. And what happens is there is air in the system, but there's no bladder. So it's just water that fills up and compresses the air at the top. Now they're a much larger tank. They're on older units, anything probably about 40 years or older. You'll see this type of expansion tank. What you have to do with these tanks is you need to bleed them. And so what you would do for that is you'd shut off the water going to it, which is coming from the boiler, and you open up this tap at the bottom, and you'll get a gurgling of water coming out. Now, it will take a while. We used to hang buckets on that little green tap and let it fill up, and it might take an hour to drain it because there's no way to let the air in. So you'll get a bloop of water coming out, and then it'll suck air in. It takes a long time for that to do that. These tanks need to be drained at least once a year or sometimes every 2 years. So if you go in and do a maintenance, you will have to drain these tanks. So what you're doing here is you're filling this tank back up with air by draining the water out. Once you've done that, you close off that green lever, open up the valve that goes to that tank, and that tank will then increase in water about halfway until you pressurize the air that you just put in there to 12 psi, because that's the pressure of the water in the boiler system. The reason these need to be drained is because that water gets absorbed into the air gets absorbed into the water. So because of that, we sometimes have to drain these off every so often. Relief valves, they're designed to relieve at a set pressure. Now on a boiler, that's not 30 psi. So the test of a lever can be used to relieve the system. So you can lift up the test lever to prove that it's working. You just don't know what pressure it's working at. We don't do this too often. The reason for that, they usually don't reseat. Once you pull them, you'll get a drip of water coming by at all times. So what we usually do is we replace these valves. Now on a commercial unit, any unit that's in a commercial boiler that's in a, I don't know, condo, apartment complex of that, you have to replace these valves. I think it's every 2 years by law. I'll have to look into that. But I'm pretty positive it's every 2 years. So, or you have to prove that they will open at 30 psi. Well, in order to do that, you have to remove it and send it away. It's easier to just put a new one on and be done with it. So it's an easy get rich scenario where you can charge a valve that might cost $50. You can charge $200 for it, and you have to replace it. But anyways, that's relief valves. Typically, if they're relieving, they're either the seat is bad on them or something else is making them relieve. So just because they're relieving doesn't mean you have to replace it. You have to take a look and see why it's relieving, why and what is the pressure in your system. So you come across a boiler with its pressure relief, the relief is open and water coming out. What could be the issue? Well, it could be one of three things. Could be a faulty pressure reducing valve, faulty pressure relief, or a saturated expansion tank, which means an expansion tank with no air in it. So here's how you would check for each one of those. Checking for a faulty pressure reducing valve, shut the system down, gas and power, drain the pressure of the boiler down to 0 psi, isolate the expansion tank, so shut that off, fill the system, the pressure should stop at 12 psi. If it doesn't, you might be able to adjust this valve. If it's still an issue, then you replace this. Remember, this guy fills the system to 12 psi. If it doesn't, there's something wrong with it, and you'll have to replace the pressure reducing valve. For a faulty pressure relief valve, or the relief valve, shut the system down, drain the pressure to 0, isolate the expansion tank, fill the system. The pressure will stop at 12 psi. Continue to increase the pressure by opening up the fast fill on the pressure reducing valve to about 25 psi or so. The valve should hold till 30, so it should not leak out. Try pulling the lever and make sure there's no blockage. If it relieves before 25 psi, replace the valve. All right, obviously. Checking for faulty expansion tank. Shut the system down, drain the pressure to 0, isolate the tank. Check the pressure on the Schrader valve on the tank. It should be 12 psi. That's a little blue one at the bottom of that tank there. If it's lower, you might need to inflate it. So it's a bicycle pump or whatever. Typically, tank, do not change your pressure. If the tank has water coming out of the valve, it needs to be replaced. Okay. So those are different ways of testing for over pressure on a system for those three things. A low water cutoff. Properly test low water cutoff. The boiler should be drained below the switch to check and see if it will open and turn off the gas. This is called what we call a true test. So what you're actually doing is you're draining the water down and until the switch opens for the low water. There's your float switch there. This one's an electronic version. This one you actually can press the button in and that will prove its worth. But on a mechanical one, to do what we call a true test, you actually have to drop the water in the system. That is a huge endeavor. that means you will have to bleed the entire system out, and you could be there for hours or days. So it's a pretty uncommon test. Most people have gone to this new electronic low water cutoff that is tested with a button. Remember, an electronic cutoff or a low water cutoff is there in case the boiler runs out of water. If it does that, you're probably looking at a big scenario here. Isolation valves are valves that are all over the boiler that we utilize to make sure that the boiler, we can isolate different areas. Now on these valves, they usually like to be either fully open or fully closed. They don't like being halfway. Those are more of a throttling valve, which we usually use like a globe valve. So this one here, if we have something called a packing nut. On bigger valves like this, you'll have a nut at the top here that you can tighten to stop the leaking. So don't be afraid that if you open up the valve and you got a little bit of water coming out of the stem and it's fully open and you got shit, it's leaking water. You actually can grab a wrench and tighten this nut on the top, and it'll tighten down on what we call the packing. And the packing stops the water from going up past this handle here. It also makes the valve harder to turn when you tighten down that packing nut. So it's a fine line that you have to do that. In some situations, you might have to cut or unthread this entire valve to replace it. Aquostats. So remember we talked about an aquostat. An aquostat is a system where the boiler heats up to a certain temperature and the aquostat opens. So even though we have a boiler that's supposed to run to 180 degrees, at 180 degrees, the aquostat opens and shuts the gas off. And at that point, the boiler thermostat will continue to run or continue to be closed because the water is at the temperature it's supposed to be. So aquostat, when it opens, it's a normally closed switch. When it opens, it's just making sure that the water is at its maximum temperature. Now, after that, there's something called a high limit. The high limit is going to catch the boiler in case it gets above the 180 degrees. That high limit aquostat is usually about 200 degrees, about 20 degrees higher. So what we typically do is we will drop or increase the temperature. So there's a high limit testing procedure. Raise the temperature control to the maximum setting. Observe the burner lights. Lower the high limit to just above the water temperature. Allow the boiler to heat up to the high limit setting. Observe the boiler shuts off. So what you're doing for the high limit testing procedure is you're going to turn the temperature down to maybe 150 or 140. And then when the temperature gets up to 140, it should turn off the gas. Once you prove that, you will turn the temperature of the high limit back up to 200 degrees. So you're just proving that the high limit is working, all right? That's one of the situations. Air eliminators. I'm zipping through this because I'm on a timer here. Common occurrence. So a couple things we want to look at for air eliminators. We want to get rid of the air in the system. Three main things that happens when you get air in the system. Rust. Excess air will create oxidization and corrosion. Noise. Air in the system can be heard and usually means there are other issues. Expansion tank, bubbling, and insufficient heat. Once you get an airlock, the water will stop circulating and the heat will stop. Manual vents have dime screws that you can release the air from the system. Float vents have a problem of leaking by, but you can replace that vent. Air purgers should be close to the boiler as possible. And micro burbler can be fouled by debris in the system. When I say debris system, you're probably looking at rust or rust particles, that kind of thing can plug off a type of air eliminator. So I'm just going to stop this video and create another quick one here in a second.